In section 2, we said we would come back to using scaled diagrams to solve vector addition or component vectors. So you could use vector or component addition that we had looked at there in the last section, or you can use a scaled diagram. So this is the fourth case we were talking about. We said we would come back to it, finding net force when forces are not perpendicular. So if you consider an object that we have here in the middle, you have three forces acting on it. One pulling it straight down. You have another F2 pulling it up and towards the right, and F3 up and towards the left. And we like to know what's going to be the overall effect here, which direction is it going to go in. So you have two options. You could use a neat scale diagram or use vector components. So if you're going to use scale diagram, you have to select the scale and combine the combine the vectors in the head-tail method. So a scale could be 1 centimeter equals 5 centimeters. It would depend on the diagram given to you, the situation, and we'll practice this in class. But I want to go over just the process here right now. You got to be very accurate with the length and angle for each vector, so you have to be careful when you're doing it by scale diagram method. To get the overall force, you have to measure the length and angle the vector from start to end of the final in the chain. So here's our overall case here to the left, showing three forces. Remember, we add these head to tail. So you got to have a starting point. So your starting point is always going to involve the middle here. So you pick a vector to start with. Doesn't matter if it's F1, F2, F3. So we draw on our F1. And when we draw, let's go, just draw it with a horizontal across. That's going to help you with your angles. The next angle we're going to decide to add in is F2. And remember, they get added head to tail. So if I draw my F1, I want to add my F2. I'll draw the tail of the first, tail of the second to head of the first. And I have to draw it at the proper angle that's going in. And then I'm going to add my last one, F3. So I need to know the length I have to draw, the force 3, and the angle it has to be drawn at. So I would start, draw crosshairs here, an XY axis. I would need to know the angle that this has to rise at. I draw my F3. And then finally, you're going to go from the tail of the first to head of the last. This dotted resultant vector is your overall answer. So you need to measure its length and angle. The order which you add the vectors does not matter. F net is always equal. So here we added force 1 plus force 2 plus force 3 and got our net. If you want to start with force 3 and then add our vectors here, say in this order, wouldn't matter. Our resultant vector would still be in the same direction, same size. So let's say we started with F3. So we drew this one in first. Then we want to draw F1. F1 would come straight down from here, from the head of the first. So we draw our F1 in, and we have to draw our F2. And our F2 will come in, and it's not connected dots between the green here and the head. You just draw on your next vector. Now our F3 is tail of the first, head of the last. So here's our first vector, right there, F3 we started with, so from here to head of the last. And if you look at both, on the left, the resultant vector, and on the right, they work out to be the same. So what we'll start with in class when I return, we'll do a quick overview of that, and then we'll go through the next series of problems.